Thanks, Karishma. So you can hear that the meeting's being recorded. We're going to record Paul's talk. We're not going to record the questions afterwards. So feel free to use the time to engage the grey matter and get some good questions for us in this session. So thanks for joining us. This is a webinar from the Health Preference Research Special Interest Group of IHEA. So the SIG, we had a number of sessions at the IHEA Congress in July, and this is the first in a series of webinars that we'll run over the next 12 months. So if you're interested in presenting a webinar, it could be work kind of in progress, or it could be work that you've finished, please get in touch with myself or one of the other organisers, which is Fern Terrace Pressholtz and Jason Ong. So it's a pleasure to introduce Paul. Paul is a PhD student at the Wellcome Trust Doctoral Training Centre for Public Health, Economics and Decision Science at the University of Sheffield. His work includes things on health state valuation, preference aggregation, decision analytic modelling. He's got an MD, doctoral degree in medicine, and an MSc in health services from universities in Germany and the Netherlands. So now he's continuing his training at Sheffield. So Paul, we're really interested in hearing about your work you'll be doing as part of your PhD, and I'm going to hand over to you now to speak for, I think we said about 35, 40 minutes, and then we'll take questions after that. So over to you, Paul.
All right, brilliant. Thank you, Matt. Thanks for the introduction, and thank you very much again for inviting me to give this webinar. So I'm really excited to talk to you today about my work on online elicitation of personal utility functions, or OPUF for short. The OPUF approach is kind of a new method for valuing health states. Currently, it's implemented for the EQ5D5L instrument, but in principle, you could use this for any sort of patient-reported outcome measure. Before I continue, I think I should acknowledge my co-authors, Ben van Hout and Nancy Devlin, who have also been involved in the predecessor study that really laid the foundation for this project. And I'd also like to mention Marika Heisen and John Brazier, but there were many other people who greatly contributed to this project in some form or the other. Okay, so my plan for the next 30 to 40 minutes is, I thought it might be useful to start with a bit of background on EQ5D and health valuation in general, just in case not everyone is super familiar with these things. Then I'll outline the two paradigms in preference elicitation and try to explain why the OPUF approach might be interesting or even useful. And then I'll talk about the OPUF, the development of the OPUF online tool, and show you a quick live demo if the technology permits. And finally, I'll show you some results from our UK study. They are still preliminary, but yeah, we recently completed the data collection there. Okay, so if we take a step back, we might say that the main point of valuing health states is really to inform health policy decision making. Because as a society, we have to make decisions on whether or not we want to adopt certain new drugs or technologies and include it in the healthcare system. And so these kinds of decisions are now increasingly informed by health economic evaluations. And well, these compare the costs and the benefits of different courses of actions, right? And in this course, to adopt or not to adopt a new drug. The health benefits are generally measured in quality adjusted life years, QALYs, and as you may all know, QALYs are just the product of health related quality of life and survival time. The costs in this equation can be measured more or less objectively, right? So we can observe this in clinical trials or in administrative data. And the same is probably true for survival times to some extent. But with health-related quality of life, things are clearly more difficult, right? Because we can't observe this objectively. And so what we need to do is first we need to specify a number of mutually exclusive health states. And then we need to translate these health states into health-related quality of life. And we do this with something that is called a social tariff. So a social tariff maps any given health state to a health-related quality of life value. And these values are also sometimes called utilities or quality weights or social values or something like that. But they all basically mean the same thing. It's about the kind of the desirability of a given health state. Social tariffs are generally based on the preferences of the general public. So what we would normally do is we would recruit a representative sample of the population in a health valuation study. We would elicit the preferences of our participants, and then we would aggregate those preferences into a social tariff. Right, and so in this talk, we are going to focus on this bit in the bottom left, right? So, and try to see how can we go from health states to health-related quality of lives, health-related quality of life, which then ultimately informs health policy decision making. So let's start with health states. There are many different ways in which we could specify health states, right? So there are many patient-reported outcome measures and disease-specific instruments and some generic instruments. But the most popular one is probably the EQ5D instrument. And so EQ5D specifies health states along 5 dimensions, and that is mobility, self-care, usual activity, pain, discomfort, and anxiety, depression. In the 5L version of the EQ5D instrument, each dimension has 5 levels, ranging from no problems to extreme problems. And so if we combine the different dimensions and levels, we can describe a total of 3,025 health states. And these range from full health, where you have no problems in any of the dimensions, to the pit state, that is the objectively worst health state, where you have extreme problems on all 5 dimensions. And then you have 3,123 health states somewhere in between, right? And for convenience, we often refer to these health states with a 5-digit number, right? So we encode health states with the dimension levels. So full health would be encoded as 11111, and the pit state would be encoded as 55555, and so on. Okay, and so now the task is to determine the social value for all of these health states. Full health, so 11111, is set to 1 just by definition, because we say 1 year in full health is equal to 1 QALY, and being dead is set to 0. But for all the other health states, we need to come up with some social value. And again, there are multiple options to do this. In the context of the EQ5D, the most commonly used method is probably the time trade-off method, the TTO, but you could also use a standard gamble for that, or discrete choice experiments, conjoint analysis, or best-worst scaling, and so on. Now, all these methods work slightly differently. They have different logics and different advantages and disadvantages. However, all of these methods belong to a particular type of preference elicitation technique, and that is a decompositional approach. In a decompositional preference elicitation approach, you would start with the description of an entire health state. So here we have a health state that is encoded as 1, 2, 3, 4, 5, right? So where you have various problems on different dimensions. And so you give this description to your participants, and then you would use one of the methods, time trade-off, standard gamble, or something else, to elicit the utility value for this particular health state. And then you would do this for a few dozen health states, and you would not only ask one participant, but you would ask a few hundred or maybe 1,000. And then you would take all the preference data that you've collected, and you would throw it into a statistical model to work out what is the individual contribution of each of the components, right? So you take all the preference data and then try to infer what is the partial value or the partial disutility associated with going from no problems in mobility to slight problems in mobility, and so on. And so this gives you kind of a scoring algorithm that you can then apply to value all the other 3,100 something health states. Right, so this is kind of the standard approach. This is what all the established methods, TTO, standard gamble, discrete choice experiments, what they're all based on. Now, the OPUF approach, the OPUF method, belongs to a different type of preference elicitation technique, and that is a compositional approach. In a compositional approach, you start directly with eliciting the partial values, right? So you you give your participants a series of exercises to directly elicit what is the partial value of the different components, right? And this gives you immediately the scoring algorithm that you need to value all the health states. And then you put those values back together to assign a global health state score to 1, 2, 3, 4, 5. In a compositional preference elicitation approach, you have very broadly, you have 3 steps: criteria weighting, level rating, and anchoring. And so for criteria weighting, the idea is to work out what is the importance of the different dimensions, right? So how important is mobility compared to self-care? And of course, it doesn't make sense to ask this in kind of an abstract way. And so you need to do this with reference to the feasible range of levels. The next step is level rating. And here you have to work out what is the position of slight, moderate, severe, and extreme problems within each of the dimensions. And finally, you have anchoring. And so this is about rescaling the dimension weights and the level ratings, because ultimately you want to map the preferences onto the quality scale, which is anchored at full health, set to 1, and DET, which is set to 0. Right. I think it's important to note that none of these methods is new by any means. So compositional preference elicitation techniques have been around since the 1970s, at least. They have been used extensively in multi-criteria decision analysis in different fields, but also sometimes in health economics. And the particular combination of methods that we are using in the online tool is also not new. It is based on a previous study by Nancy Devlin and Ben van Hout and a few other people who have pioneered this approach, and they devised like a 7-step approach to elicit preferences for the EQ5D 3L, right? So this is not the 5L version with 5 levels for the EQ5D, but 3L with 3 levels. And so, but their approach, so this study was back in 2015, and their approach was very much focused on reflection and deliberation. So they went to visit their participants in their homes, and they had long face-to-face interviews where they tried to really help the participants to reflect on their choices and to ask them to explain their choices. And so, well, basically to help them to create very solid, well-informed preference functions. Now, what I've been trying to do for the past year, I guess, was to take what they did, refine it slightly because there were some minor issues with the approach, adapt it for the 5L version, and then move it into an online environment. So that means going from long, deliberative face-to-face interviews to a short, easy to use kind of online survey. The online survey that we created is built in Shiny. That is an R package that allows you to build interactive web interfaces. And so in the beginning, we started just by experimenting with different options on how can we emulate what they did in face-to-face interviews. How can we emulate this on a website, right? So we tried different rating scales or sliders and buttons and so on. Yeah, right. And so this is the first version of the tool. This is what it looked like. But from there, it really took a couple of iterations until we arrived at the final version. And I also did online interviews, kind of think aloud type of interviews with about 30 participants in 5 rounds to just ask them, like, to see how they interact with the tool, to see if there are any issues, and then when we have identified issues, go back to the tool, revise it, and then do another round of online interviews. And so I think these interviews really helped me a lot. They were super interesting, and they definitely helped us developing the tool. So one of the lessons that I had to learn in these interviews, I guess, was that people have very clear, very strong expectations on how a website ought to behave, right? So everyone has used so many websites and online surveys, and they all have common features, and they all behave in kind of a similar way. And so if you get this wrong and you present the task in a way that is kind of unusual, people can very easily get confused and also frustrated. And so we really spend a lot of time just trying to get the online survey to work in kind of a smooth way and kind of in an expected way. And just to give you one example, so in the online survey, we have a couple of pairwise comparisons. So here we ask people to compare two different health states, scenario A and B, and then they need to click on one of the buttons to say which one they prefer. And once they clicked on the button, one of the health states would change. But in the interviews, I realized that often people didn't notice the change, right? So they didn't see that a new health state has appeared, and so that now it's a different task. And they thought, well, nothing had happened, and they would click again, or they would assume that the website got frozen. And so what we did to solve this is we implemented these kind of loading animations. And so this is really a bit funny because there's really no loading going on whatsoever, right? So the server is fast and the computation are really easy. So the loading time is almost instantaneous. But we ended up using these loading animations in several places in the online survey to kind of indicate, to show the users something is happening. And so this was really helpful in kind of directing the user's attention to certain elements. And one other learning that I found really interesting is, so for most of the task, we started off with a very long description. So because we would try to explain the task as good as and as comprehensive as we could. But we had to learn that most people really don't like reading long texts online. And so with such a long text, they would often skip certain parts or they would get confused. And so we incrementally cut down the text, so we made it shorter and shorter. And ultimately, we ended up with really short, very direct instructions. And so instead of giving long, elaborate explanations, we try to just present the task in a way that is so intuitive that you don't need a long explanation, and people would just get immediately what the task is about. Right, and so now I would try to give you a quick live demo of the online tool. I guess I need to change my sharing options, right? Just 1 second. Can you see my web browser now?
Yes, we can, Paul. You're very brave.
Brilliant. Yes, I am. Let's hope the technology works. Okay, so this is just the landing page. And so if we click start the survey, oh, I need to. Yeah. So this is the first question. So here we are just asked to report our own EQ5D health state, and so we just click the items that best describes our health today. I'm slightly anxious. And so this is useful for us, of course, for the analysis, but it's also useful for the participants because they get introduced to the instrument and they see what kind of aspects we're focusing on. This is the EQ VAS, so this is a visual analog scale, and here we ask to indicate how good or bad our health is today, just on the scale. And the scale goes from 100, which means the best health you can imagine, to 0, the worst health you can imagine, and then you just click on the scale, and then this bar appears, and you can set the bar wherever you think it fits. Okay, so the next step is the first valuation task. So this is the level rating, and so we take the visual analog scale from the previous task, but now we say, okay, a person with 100% health has no health problems. A person with 0% health has extreme health problems. And then we ask, okay, at what level of health does a person have slight, moderate, and severe problems? And so we start at the bottom left, we start with slight health problems. So we say, okay, how much health does a person with slight health problems have left? And then we are asked to click on the scale here to place the label on the scale. And then in the bottom left, you saw the loading animation, right? So there's no loading, but this indicates, oh, now we have to do the same with moderate problems, right? And so we do this for moderate and then also for severe. And afterwards, you can adjust the levels, of course. Now, ideally, you would want to do the level rating task for each of the 5 dimensions separately, right? So you do one for mobility, one for self-care, and so on. However, we figured that this might be quite repetitive, right? So imagine doing this task 5 times in a row. And so we made the decision to elicit the level rating task kind of in a global sense. So we don't refer to any particular health dimension. We just say in general, like health problems. And so then we would use the level ratings and apply it to all 5 dimensions in the same way. But of course, this is simplification, and people may want to be more comprehensive here. But I guess it's always just a challenge to strike the right balance between ease of use on the one hand and kind of comprehensive elicitation on the other. Okay, so this is the ranking exercise. So here we are asked, we see the 5 worst levels on each of the dimensions. So I'm unable to walk about is kind of the worst level for mobility. I'm unable to wash and dress myself is the worst for self-care and so on. And we are asked to rank them from worst to best bad. Right, and so for this, we just move them on the right side. And I guess this task is useful because it introduces the user to the idea that you can compare different health problems, which is not something that many people do often. And we also use the responses in the next task. So here, for example, I've ranked, I'm unable to walk about as first, like this is for me, this is the worst problem. And so if we continue to the next task, then here we say, okay, you selected mobility as the area that is most important to you. And then now if an improvement from I'm unable to walk about to I have no problems in walking about is worth 100 health points, how many points would you give to improvements in other areas, right? So that means we take this improvement in mobility and set this to a value of 100. And now we say, okay, take this as a yardstick to assess the importance of improvements in other areas, right? So this is our yardstick, and then we can set the weights for this improvement in self-care, and we can use a slider to set the value here and for the other dimensions. And you can also note that the order in which the dimensions are displayed on the page is corresponds to the ranking from the previous exercise, just to make it easier for the users. Okay. Now this is just a discrete, classic discrete choice experiment where we have 2 health states and we ask about which health state is better. And we use color coding to just make the task easier for the participants. The responses for this task are not used to construct the personal utility function, just kind of a validation exercise. And also this task is personalized, so every participant may see a slightly different task here. And after 3 sets, we continue to the next task, and here this is the anchoring step. So it's again a comparison between 2 health states, but now one of the health states is being dead. And in scenario A, we always start with the pit state. And so if a participant says they think that being dead is better than scenario A, the pit state, so then we click scenario B, then the state in scenario A changes, and we start an iterative search to find the health state that is equal to being dead. So in the background, the server has taken the level ratings and the dimension weights and constructed a simplified personal utility function. And this allows us to create kind of a personalized ranking of the health state, right? So we can rank all the 3,125 health states from best to worst for this participant. And then if the participant says, okay, the worst health state is worse than being dead, and we know that full health is better than being dead, well, then there must be one health state that is equal to being dead, right? And so then we use something that's called half interval or a binary search algorithm, just a simple search algorithm to look through the different health states to find the one that is equal to being dead. And after 6 of these questions, 6 of these iterations, we are very close to the health state that is equal to being dead with like a maximum error of 1 or 2% in terms of the rankings. But of course, if you think that the pit state is better than being dead, then this task doesn't make any sense, right? So if we restart the task. So here, if you say, I think the pit state scenario A is better than being dead, then we have no idea what the value of the pit state is, right? So because we know it's better than being dead, so it's above 0, and it's probably worse than full health, so it's below 1. But where on the scale it is, we have absolutely no idea. And so if participant says, okay, in this comparison, I prefer scenario A, then we immediately go to a different task. And he will say, okay, so you said for you having so extreme health problems, so scenario A is better than being dead. And so then we ask, well, how much better? And so here we have scenario A, and we again use a scale from 100 to 0. And now 100 means no health problems, and 0 means being dead. And then we ask, where on the scale do you think scenario A should lie, right? And so then you can click on the scale, and then an arrow appears and the value, and then we can set the position of the state wherever we want. Right, so the next page is just some demographic information, just a normal survey, but we can skip this now. And go on to the results page. So this page is really just supposed to be kind of a something like a thank you for the participants. So here they have an opportunity to compare their personal results with the general population average, right? So for the ranking exercise, they can see how they ranked their the problems and how the general population ranked them. The same for the level rating, and they can also see some assess the health state score. So here they can see the score that we think based on their personal utility function, what score this health state has for them, and then compare this with the general population for health states. They can download the results if they want to, and yeah, that is pretty much it. Okay, so now if I switch back to the presentation. Where's my presentation gone? It's not there anymore. Oh, there it is. Are we now all back to the slides?
I think so, Paul. If you just go to your next slide, just to make sure. You see a slide with a link over the top. Yeah, you're back. Keep going.
Okay, brilliant. Okay, so now I'm going to show you a few results, a few preliminary results from our UK study. I don't want to go into too much detail here, but just show you a few kind of illustrative examples of what kind of analysis you can do with the OPUF approach, right? And so we recruited 1,000 participants from the UK. We did this through the prolific online research platform. The sample was supposed to be representative in terms of age, sex, and ethnicity. Unfortunately, we had to exclude data from 126 participants because they skipped one or more of the evaluation steps, and so then we couldn't really use the data in any meaningful way. This was quite annoying, but I guess this is something that you always have, like it's unavoidable with these kinds of online panels where you have people who just don't pay attention or just click through or something. And so ultimately we used data from 874 participants for the analysis. So the first thing we can do is to look at the level rating. So here you see the distribution of values that people assign to slight, moderate, and severe problems. And well, what you see here is that people clearly like round values, right? So for slight, people often set the slider to 90 or 80, and for moderate, it's often 50. But you also see some variation to the left and to the right. Then there's the dimension weighting. So here you see the distribution of weights that people assign to the different dimensions. And again, here we see that pain and discomfort is clearly the most important area on average. So yeah, and followed by mobility and self-care, which only differ in kind of this in the second decimal. So they are pretty much even. And then comes anxiety, depression, and the least important dimension seems to be usual activities, which I always find kind of surprising, because for me it would rank higher, but I guess this is just personal preference. And we can also look at the anchoring factor. So here we see the value that people assigned to the pit state. In our sample, 39% said they think the pit state is better than being dead. And for those, we would use the value from the visual analog scale. And 61% said that dead is better than the pit state. And for those, we would use the response to the iterative search. And well, the average value for the pit state was minus 0.37, but you can see that there's really a lot of variation going on. Okay, so now we can combine the level ratings with the dimensional weights and rescale those with the anchoring factor, and then aggregate all the preferences across the 874 participants. And this gives us the social tariff, right? So this is the social tariff for the EQ5T5L based on the OPUF approach. And what's also kind of worth noting here is, that even though there was quite a lot of variability going on, that we are able to estimate the mean values kind of with a very reasonable precision, right? So the 95% confidence intervals are quite narrow. Okay, and so this is now the scoring algorithm that we can now use to assign a value to all the 3,125 households. And this is what you see here. So this is kind of a visualization of the social value function. So on the y-axis, you have utility or health and quality of life. And on the x-axis, you have all the 3,125 health states ranked from the best, full health, 11111, to the worst, according to the social preference, right? And then you can assess kind of the shape of the social value function. And now what we can do is we can look at group preferences. So we can estimate a value function for men and women, for example, separately, right? So here you see these two value functions. And I mean, the difference between the two is really minuscule, but you can see two different things going on here. So first, you see that the value function for women is slightly below the value function for men. And what this tells us is that women are more willing, or they focus more on quality of life. So they might be more willing to give up survival time for gains in quality of life compared to men. And the second thing that we can notice is kind of the slight wobbling of the graph, right? So the line is not exactly smooth. And so this tells you that compared to the overall average, there's some variability in terms of the level ratings and the dimensional weights, right? So it's very minor, but there's some differences there. Now we could do the same for education or for ages, like we could compare the preference of the young versus old and so on. But these kind of analysis you could also do with time trade-off data or discrete choice experiments. What the OPUF approach allows us to do is really to look at much smaller subgroups. So here you see the value function for women between the age of 30 to 40 with a university degree. And this is the value function for the group of healthcare professionals in our sample. And the third one is, so this is the value function of a small group of people who reported severe and or extreme levels of anxiety and depression. And I mean, these groups are chosen more or less randomly, and you could look at many other characteristics here, but this is just to show you that we can estimate a group level preference function for relatively small subsamples, right? So the last group only has like 37 participants. And so if you would be doing, if you were doing like a time trade-off or discrete choice experiment study, you just wouldn't be able to estimate a preference function here, right? Your statistical model just wouldn't converge, or the coefficients would be completely nonsensical. And with the OPUF approach, we can estimate the group preference function and compare to other smaller subgroups. But of course, the OPUF is really about personal utility functions. And so here we can now go one step further. And so if we focus on the last group of people with anxiety and depression, we can break this down and look at the individual level preference function for all the participants, right? So here you see the personal utility functions of the 37 members of this group, right? So every line is one preference function. And I guess what you can see here is really what I find generally in this data set, that the preferences, the differences between groups is not that big. I mean, there's some differences, but compared to the variability of preferences within groups, I mean, there's really vast variability within groups, right? The differences between individuals is much larger than the differences between groups. Right, so now you could, of course, question whether these personal utility functions are valid. Like, do they really reflect the true preferences of the individual? Now, this is, of course, a tricky question because, well, we have no way of knowing if such a thing exists or how to elicit it, right? There is no gold standard that we could use to then compare our method against. However, what we can do is to look at consistency across methods. And so in our survey, as you've seen, we included 3 discrete choice experiments, right? And now we can use the personal utility function for all the participants, and we can predict, like, based on their utility function, what kind of choices should they make. And then we can compare this with the actual choices. And what we find is that the overall consistency is 78.5%. And I would say this is quite a high value, given the fact that in a discrete choice experiment, you would expect some errors anyway, right? So DCE is based on the idea that people make errors. And we can also see that most participants didn't make any errors. So the majority made 0 errors. A third made 1 error, 12% made 2 errors, and 2% managed to get all 3 questions wrong. And we can also see that the people make less errors if the task is easier. So you can show 2 health states that are further apart, right? So in terms of utility, they're very different, and then the task is easier. Or you can show 2 health states that's very close together with a smaller utility difference, and then the task is more difficult, of course. And what we find here is that even when the task is difficult, we are still able to predict the choice of the participants in 68% of the cases. And one last finding from our study that I thought I'll share with you is kind of the feedback. So on the last page of the survey, we included a tiny sentence where we said, well, we would love to hear what you think about the survey. You can click this link to send anonymous comments. And so I didn't really expect much there, but I think I received about 60 emails from people who shared their views. And so, I mean, of course, some of these comments were kind of negative remarks, but they were largely really positive, and people shared very personal stories on what they were thinking while going through the survey, why they made certain choices. And so I guess this was just really nice to see that after spending so much time and effort and just getting the questions right and the task and so on, it was just really rewarding to see that some people apparently seem to enjoy the survey and they found it interesting and thought-provoking. Yeah, it was just really nice personally for me. Okay, to summarize, I think the results from our study, even though they are preliminary, they show that it is feasible to use the OPUF approach to estimate a social value set, or like a value set for on the social level, on the group and on the subgroup level, and also on the personal level. The main advantage of the approach is probably the efficiency, because if you would be using time trade-off or discrete choice experiments, you would normally need to recruit 100 or better a few thousand people to fit your statistical model. And with the OPUF, well, we can work with individual level preferences, and if you're interested in group level preferences, I suppose just a few dozen participants would suffice to be able to estimate like a mean preference. And I guess this this might really open up kind of new opportunities because so in situations where you don't have a budget to recruit 1,000 people, or if you're interested in kind of the group preference of like a small patient group, for example, the other methods just wouldn't work, right? And so here I think the OPUF tool could be really useful, maybe. Another advantage might be the transparency of the methods, because with discrete choice experiment data, for example, you have to fit, I think, rather sophisticated models. Like a mixed logit model is for me at least nothing that I can easily explain to decision makers, for example. And also, people now try to combine discrete choice experiment data with time trade-off data and so-called hybrid models, and they use these fancy Bayesian methods. And I must admit, I generally don't understand what's going on behind the curtains. And so with the OPUF approach, the methods are really so simple that you could, in theory, just work it out with a pen and a piece of paper just by your own. And so I think this might be really attractive if you want to communicate your results with decision makers, because you can show them really where are the numbers coming from. Now, directly connected with this is probably the main disadvantage, and that is you have to make rather strong assumptions about the functional form of the model, right? So in our study, we assumed an additive linear model, and with compositional preference elicitation methods, it's also not entirely straightforward to test for interactions between dimensions. And so this is certainly a limitation, but I guess I would argue that it's not completely unreasonable to make these assumptions because most health valuation studies use an additive model. Very few people include interaction terms, and if they do, they often find that the model fit does not improve dramatically. But of course, people may disagree here. The key challenge for this method is probably the acceptability, right? So it's a new method. It's based on a different paradigm than the established methods, and so people may question the validity and they may be hesitant to use it. But I guess this is a question that I maybe put back to you, and because I would be wondering what you think about the method and what your concerns are, and what kind of evidence or what kind of information you would need to be convinced that this is a good method that you can use for your next research project. And next steps. For me, I guess the immediate next step is to finish the data analysis, and there I'm really focusing on the preference heterogeneity, right? So try to explain the vast variability of preferences between people. But after that, I think it would be really interesting to try to replicate the study in kind of a different setting, because right now I've only used the OPUF tool to elicit preference for the EQ5D5L instrument, but in general, the OPUF approach is more general, right? So you could, in principle, you could use it to value any kind of patient-reported outcome measure. And so I would like to try that also to see how easy it is to tweak the methods. So to not just on a conceptual level, but also really on the practical level, like how easy is it to change the underlying source code of the online tool to make it work with a different instrument. Because ultimately, of course, I would like to make this method available to other researchers so they can easily use it for their research projects. But I guess this will require a bit more thought and a bit more work. And with this, I would like to thank you very much. Thank you very much for your attention. And I'm looking forward to your questions and your comments.
Thank you, Paul. I'm sure you can hear the